Kepler's third law states that square of period of revolution of a planet around the sun is proportional to third power of its average distance between the sun and the planets. That means t square is directly proportional to r cube, or t square is equal to a constant k into r cube, where k is a constant. If mass of sun and the planet are m and m respectively, then as per the Newton's law of gravitation, the force of attraction between them is g m by r square. Here g is universal gravitational constant. The relation between g and k is described as. So our aim is to write the relation between this g and k. So we can write it like this. The value of t square is given as nothing but a constant k into r cube. So we can find out the value of k, and then we can find out the relation between this g and k. So we know that when an object or a satellite is moving around or a planet is moving around sun, so we can assume that if it is moving in a circular path of radius, let's say that is equal to r, then the forces acting on this satellites are or a planet is nothing but the force exerted by the sun on the planet. Let's say the force of the mass of sun is m, and the mass of planet is equal to small letter m. So the gravitational force, we can write it as equal to g m into m divided by distance is r square. This is equal to the values. This is going to provide that centripetal force. So if it is moving with the velocity v, we can take it as it is mv square divided by r. We are just equating the gravitational force to centripetal force. So we'll get we can cancel this r and this r, this m and this m. So we'll get the value of orbital velocity, which is equal to a root of gm divided by a root of gm divided by r. Now from here we can find out the value of time period. So for time we can just use that equation, distance divided by velocity. So when it's complete one full rotation, then distance traveled will be equal to nothing but 2 pi r circumference, and 2 pi r divided by the value of velocity, which we can take it as the root of gm divided by r. So if you are squaring on both the sides, we'll get as it is t square is equal to 4 pi square r square divided by gm by r. So which can be written as nothing but 4 pi square divided by gm and into r cube. So we can write this t square is directly proportional to r cube. So in question, according to this question, it is given that t square is equal to k into r cube. So instead of k, we'll have this term. So we can say that the value of k in this situation is nothing but this particular term. K over here is nothing but 4 pi square. We can write the value of k is equal to 4 pi square by gm. So we can write the relation between this k and g, that is k is equal to 4 pi square by gm. Yeah, according to the options, we can write g into k is equal to 4 pi square divided by m, or g into k into m is equal to 4 pi square. So according to the options, we can say that this D option is correct.